Okay, so before we start this test, we want to take a look at just ranking. So let me give you some numbers. Let's say 10, 8, 12, 16, 12, 8, 5, 3, 4, 12, 11, 19, 20. Okay? So let's say this is our sample of numbers, and we're asked to rank these numbers, right? So first let's see how many we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, okay? So I'm going to put 13 spots. 1, 2, okay, so I'm going to label that S. Those are my spots. There's 13 spots. Okay, then from smallest to greatest, we're going to put these in order. So let's see here. What's my smallest? It looks like 3, 4, 5. And don't let me mess this up. 3, 4, 5. Then what comes next? We have 2 8s. Is that right? 8, 8. And then 10, 11. And then looks like I have 3 12s, so 12, 12, 12. Great. And then 16, 19, 20. 16, 19, 20. Okay, so these are my actual numbers, and then I'm going to put R here, because now we're going to rank these numbers, all right? So here's what happens. The ranking is like first place, second place, third place, fourth place, okay? But it gets tricky is when you have a tie. All right, so the rank for 3 is going to be 1. The rank for 4 is going to be 2. Okay, it's like first place, second place, third place. And then here we go. We go right into a tie, right? I have an 8 for the 4th spot and an 8 for the 5th spot, okay? So the way the ranking works is you take the average for what spots it took up, and that will be the rank, all right? So notice we have spots 4 and 5. If you average that, you get 4.5. Is everybody with me on that? So 8 gets a rank of 4.5. 4.5. And then you pick up with the next spot. So the next rank should be 6. Is everybody with me on that? So 6, 7, and then we have a 3-way tie. We have 12, 12, 12 for spots 8, 9, and 10. Okay? So if I rank these spots, I need to average spots 8, 9, and 10. Well, if you add 8 plus 9 plus 10 and divide by 3, what are you going to get? 9. So these are all going to get 9, 9, 9. Okay? And then we pick back up with the next spot. The next spot's 11, then 12, then 13. Okay?
So we do the average of the spot?
Average of the spots. When there's a tie, do the average of the spots. That's a great way to remember it. Whenever there's a tie, do an average of the spots. Okay? And that happened here, and it happened here. All right? Any questions on that? So it's super important that you're able to do that because we're going to have to do that in the next several hypothesis tests that we do. Okay? All right, great. Make sure you can do that, and let's move on. So today we're going to look at the Wilcoxon Rank-Sum test. Wilcoxon Rank-Sum test. So it should be pretty clear in the name of it that you're going to do some ranking, and we're also going to do some summing, okay? All right, let me just list out the steps real fast, and then we can go through the test. Okay, so the steps, number 1 is going to be HO and H1. And again, it's going to be somewhat descriptive with our non-parametric stats. Step 2 is you're going to do critical value from the normal table. Okay, so that should be fairly easy because we're really confident and comfortable with the normal distribution by now. And then step number 3, we have a couple of steps to determine this test value. Okay? So I'll have a little bit of, let's do 3A. You're going to combine data from both samples and arrange it in order and rank each value. Okay, so 3A will be combine all data together and rank what we just looked at, each value. Okay? 3B will be sum the ranks of the group with a smaller sample size, and we're going to call that N1. Okay? So sum ranks of N1, which is the group with smaller sample. Okay, so one question that might come up right away is, what if they both have the same sample size? Then it's your choice, okay? So if they both have the same sample size, then just choose one of them will be N1. But if one clearly has less than the other, then that's going to be N1. The smaller sample is always N1 for us. All right? Okay, and then this is our test value. So 3C, this is what your test value looks like. Z equals, because we're using our normal distribution, capital R minus mu sub R divided by sigma sub R. All right? So we have to define each of these. Capital R is the sum of the ranks of N1. The sum of the ranks of the smaller sample size. Smaller sample. Okay? Mu sub R and sigma sub R are just formulas. So here's your formula for mu sub R. N1 times parentheses N1 plus N2 plus 1 all divided by 2. Okay, it's just a formula. So it's N1 times parentheses N1 plus N2 plus 1 in parentheses all divided by 2. Now if N1 is the smaller sample, then N2 obviously is the larger sample. Okay? Again, unless that one instance where you have the same sample size for both. Okay? And then sigma sub R is another formula, our standard deviation. It's a big square root, and we have N1 times N2. So N1 times N2, parentheses N1 plus N2 plus 1, all divided by, and this is all underneath the parentheses, 12. Okay? So please make sure you have all of that information, because that's what we're going to have to do when we go through the problem.
It's always 12?
Yes, 12. This one's always 2, and this one's always 12. Okay? Wilcoxon Rank-Sum test. You're going to sum the ranks of the smaller sample. Okay, so keep that in your head. We're going to be summing the ranks of the smaller sample, and that's what R is. Okay? All right. Let's jump right into an example. These things take a little bit of time, so we'll probably only be able to get through one of these. But let's be really careful and do it step by step. Okay, here's our problem. In the table below, the length of sentencing for a particular crime for a random sample of men and women at a prison. At alpha equals 0.05, test the claim that there is no difference in the sentence length received by each gender. Okay? So here we go. Our question is, at alpha equals 0.05, test that there's no difference. No difference in sentence length by gender. Okay, so we have a particular crime here, and we have how long the sentencing was for males and females in a random sample of people that committed this particular crime. Okay? All right, so this is in months. This is sentencing in months. I'll just make a column here, and this is males. And this is how many months they received for that crime. Okay, so we have 8, 12, 6, 14. 8, 12, 6, 14. That's how many months they received. 22, 27, 32. 22, 27, 32. 24, 26, 19. 24, 26, 19. and 15 and 13. And again, this is in months. So we have this particular crime, and this is how many months the males received for that particular crime. Okay? Now let's do the females. We have 7, 5, 2, 3. 7, 5, 2, 3. 21, 26, 30. 9, 4, 17. 23, 12. And 11 and 16. Okay, so one of the first things you need to do is determine which sample size is smaller. Okay, so what is n? How many males do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So n is 12 for the males. And let's see what the n is for the females. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So everybody see that? Okay? So now I can label which one is N1 and which one is N2. Which one is N1 in this problem? Males, right? Because it's smaller. So N1 is the smaller sample size, and N2 is the bigger sample size. Okay? So please be clear on that. Usually in all the stuff we've done before, we just take the first sample and we call that L1. Okay? But now you want to be really clear. Whichever sample is smaller, whichever sample size is smaller, that's N1. And this one's N2. Okay, so we have a lot of work to do. The first thing I want to do is start looking at the ranks, okay? So how many spots am I going to have total if I combine all of these into one big string? How many spots total am I going to have? 26, okay? So go ahead and start making 26 spots on your piece of paper, all right? 26 spots. So however that works, 1, 2, 3, 4, maybe I'll do 2 of 13, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, and 26. Okay? I have 26 spots. Now I have to go through them really carefully and list them in order from smallest to greatest. So that's going to be fun. So looks like 2 is the smallest. So 2, then 3, then 4. So don't mess this up. It's hard when you're so close to it. 5, then 6. Okay. And also, as you're going through this, you want to label what is what. Okay, so 2, 3, and 4, and 5 were all females. So I'm going to put F, 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 F. 6 was a male, so I'm going to put M. Okay? Because remember, I'm going to sum the ranks of the smaller sample size, so I'm going to only sum the ranks of the males. But if I don't list which is which, I won't know which one's to sum in a minute. Okay? So let's keep going here. After 6, we have 7, and then 8. So 7 is a female, 8 is a male, 9 is female. Okay, is everybody clear as what I'm doing? I'm just listing it in order from least to greatest, and I'm labeling what is what. Okay, so then 11 is female, and we have 2 12s, a male 12 and a female 12. So 12, 12, male and female. Then 13, male, 14, male, halfway there, 15, male, 16, female, 17 female. Then 19 male. 21 female. 22 male.
Right?
23 female. 24 male. Let's see, two 26s. We have a male and female 26. So 26, 26, male and female. Almost there. We have 27, male. And 30, female. And 32, male. Okay? So, again, there's no shortcut for that. That's just going to take time. Okay? That's actually the hard part. The easy part is now just going to be the ranking it. So are we ready to rank? So it's just first place, second place, third place, fourth place, fifth place. Oh no, I have a tie. Sum up the average, or I'm sorry, don't sum, do the average of the spots. Okay, so here we go. I want to make a third column and call it rank, R. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Here's my first tie. Spots 10 and 11 have a tie, so they're going to get ranks of 10.5. 10.5. And then just continue with my next spot. 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Spots 22 and 23 have a tie, so they get an average of 22 and a half. And then you just pick back up with your next spot. 24, 25, and 26. Okay? And that's it. All right. I'm going to circle the ranks of the males, because that's the smaller sample size. So 5, 7, 10 and a half, 12, 13, 14, 17, 19, 21, 22 and a half, 24, and 26. Okay? And the reason why I circle those ranks, because when I get to my test value, I'm going to sum those circles, and that's going to be R. Okay? So have all of that ready, and now we can actually do the test. Okay? So HO, H1. I'm going to erase this step. Step 1, HO, H1. Okay? So again, if there's a difference in sentencing by gender, you need to put that in the H1. That needs to be shown. We just generally assume that there's no difference in sentencing by gender. Okay? So HO is going to be, there's no difference in length of sentence by gender. For males and females. Okay? And H1 is there is. So it's very descriptive, but our assumption is that everything's equal. Okay, then our critical value uses the normal distribution. So open up to table E. This is a two-tailed test because it's like equals, not equals. And what did I give you for alpha here? 0.05, okay. So that's going to be 0.025 here. And 0.025 here. So this is very old school for us. So go to your normal distribution and look up these critical values. And what do you get? Yep, positive 1.96 and negative 1.96. Okay? And that's it for step 2. Right? It's old stuff that we've done a million times. Normal distribution, 0.05, 2 tails, 0.025, 0.025, and look them up in your chart. Great. Step 3, test value. All right, what does my test value formula say? It's Z equals capital R minus mu sub R divided by sigma sub R. Okay? All of these are formulas, right? Capital R is adding up the ranks of the smaller sample. Adding the sum of the ranks of the smaller sample. And that's what these circles are. So add up these numbers. Those are the ranks of the smaller sample. So add them up and see what R comes up to. So it's 5 plus 7 plus 10.5 plus 12 plus 13, on. And see what you get there. What do we get for R? $191 is what I got. Did everybody get 191? Okay, and again, that's just adding up those circles there. Okay? Adding up the ranks of the smaller sample size, which in this case was males. Okay, mu sub R, let's move to that one. That's just a formula, right? So I'm just going to squeeze it in right here. Look at your formula. It's N1, which in this case, I erased. What was N1? How many males are there? 12. Parentheses, then N1, 12 plus N2, 14 plus 1, right? So 12 plus 14 plus 1. And all of that was divided by 2. Okay, so in your calculator, you have 12 times 27 divided by 2. Let's see what that comes out to. $162. Okay, so that shouldn't take too long. You should get mu sub R is 162. N1 times N1 plus N2 plus 1, all divided by 2. Comes out to 162. So I have R, I have mu sub R. Now let's do sigma sub R. That one's a little bit more complicated. It's a big square root. The top is N1 times N2. So I have 12 times 14. Okay? Then times this same guy right here, which we've already looked at. 12 plus 14 plus 1, which is 27. So you have 12 times 14 times 27, all divided by 12. All underneath square roots. So go ahead and calculate that. This one's kind of nice because these 12s cancel out if you want to shorten it. But in any case, you should get, if we go 4 decimal places, 19.4422. Okay? And those are the 3 main things that we need to do the test value. So here we go. We're ready to go. Z equals R, 191, minus mu sub R, 162, divided by sigma sub R, 19.4422. And let's see what we get for that. 191 minus 162, enter, divided by 19.4422. You get about 1.49 approximately. 1.4916-ish. Which is not big enough to be in our rejection region. So 1.49 is maybe right here. So my test value falls in my non-rejection region. So finishing up the problem. Step 4, do not reject HO. And what happened? Well, if I don't reject HO, I'm saying there's not enough evidence to suggest there is a difference between length of sentence by gender. Okay? Long problem. It's really easy to mess up in the ranking. Okay? So I would suggest be really, really careful with putting down all of your spots, putting down all of the ranks, and labeling which is which, okay? And then just circle the ranks of the smaller sample, and that's what you're going to add. That is your capital R, the sum of the ranks of the smaller sample. So get that right, and the rest of it's pretty easy, okay? This part is the easiest part to mess up on, okay? Any questions on the Wilcoxon Rank-Sum test? Your ranking and your summing.